All right, today we're going to be talking about systems of inequalities. So we've previously talked about systems of equations. Now we're going to look at the same kind of setup except with an inequality. Now there's a couple differences here, and so I want to lay those out between an equation and an inequality. Two of those things are the line. You can have two choices whenever you're looking at this. You can either have a dashed line or you can have a solid line. Now, whenever I'm looking at the difference between these two, a dashed line happens if I have a less than or a greater than symbol. So that means it goes up to that line, just doesn't include it. So we have that dashed line that goes with it. A solid line happens if it's less than or equal to and greater than or equal to. So then this means that your graph could actually go up to that line and include the line. So that's where you're looking at the dashed or solid, the differences between those two. Awesome. Another thing that's going to be a difference between an inequality is because there's more than one answer. So we have to look at it and say, okay, we have to represent every answer that's possible. So when you do that, it's going to be shaded. So then you look at your shading and you say, okay, is this going to be above or below? Typically, with your shading, if you have y and then some function, so whatever the equation is that goes after your y, so your equation, whatever, be it a line, a parabola, whatever you've got going for you, if this is less than or equal to, so maybe I should write that, or less than or equal to, so the point is on the y part that I'm looking at, then the y values, if you look at a coordinate grid, your y values, as they get smaller, then you go down below, right? So the y values get smaller and smaller down below. So if I want to say I want to make all of the y values here that are less than your equation, then I am going to shade this below the equation, because that's what makes my statement true. All the y values that are less than whatever my equation is, those are the ones that are below, and that's what makes it true. Cool. If I have y, so whatever function I have is greater than or equal to my equation, whatever that ends up being, then think about what this is going to happen. If I go up, then my y values get bigger, right? So if I want all the y values that are bigger than my equation, then I'm going to shade above that equation. So a couple differences there. You either have a dashed or solid line depending on your symbol, and if the y values are greater than or less than whatever equation it is that you're graphing, that's going to determine shading. Since an inequality has more than one answer, we have to account for all of those answers. Okay, let's do some. So for this one, I have a line, right? So we're going to graph this line and we're going to shade appropriately. Anytime you graph a line, the first thing that you need to do is get this in slope-intercept form. That way we can work with it. So let's do that right now. The first thing that we're going to do is I'm going to subtract my 3x from both sides. So I have a negative 2y is less than or equal to a negative 3x plus 6. And remember, 98% of success in mathematics is organization. So the goal is to put this in slope-intercept form. So whenever I write my x, I always put it closest to the symbol, so that this puts it in that mx plus b format. Cool. Now, with this problem, I'm going to divide both sides by a negative 2. I like to divide everything by that negative 2 since it's that plus in between there. Tell me what happens if you have an inequality and you divide it by a negative. Yeah, you guys are on it. Flip that sign. So y is now greater than or equal to a positive 3/2 x minus 3. So my slope for this problem is going to be that 3/2, and my y-intercept is a 0, -3. Now here's the real question. Whenever I go through and I'm looking at this problem, my real question now, is this going to be a dashed or a solid line? Good, it's a solid line because it's or equal to. That means the line is also part of my solution. But because it's an inequality, I have more than just the line as a solution, so we want to shade. Where are we shading to show the rest of my solution? Yeah, above, because this is greater than, so the y values that are greater than my line also make it true. So I'm going to shade this above my line. Cool. Let's do it right now. So if I'm going to graph this, I start down here at -3 for my y-intercept, because remember you begin with a y-intercept, move with a slope. So now I'm going to go up 3, 1, 2, 3, and run 2, 1, 2, and then make my next point. You can make as many points as you want. We could go up 3 again and over 2 to make another point. If I wanted to go in the other direction, then I'm just going to take this down 3 and back 2. Because this is an inequality, I would suggest making as many points as your little heart desires, because it doesn't end, right? That's why we put those arrows at the end of the lines, because that shows my line doesn't end, it is infinite. So it's really just good practice to fill that whole thing up. Now I know that I'm going to shade this above, so just fill it in. It doesn't have to get fancy, just kind of mark it in and shade it in. Everything above that line, and in this instance, including that line, because it's solid, is part of my solution. Super cool, right? Let's do another one. So we've got ourselves another line here. Let's go ahead and get that y by itself and solve for this. When you subtract x from both sides, I now have 4y is less than a -x plus 4. Divide everything by a 4. So we want to divide each term by a 4 because there's that plus sign in the middle. Now, am I going to need to switch my inequality symbol on this particular problem? No, good, because the only time you switch that inequality is if you are dividing or multiplying by a negative number. And here I'm just dividing by a 4, so we're good with that. Good. Also notice the fact that whenever I wrote this 1/4, when I divided by 4, I wrote this as a 1/4 in front, so that I can show that as a slope rather than just dividing by 4. I don't think it's as obvious that it is a slope there. Cool. So speaking of slope, I know my slope for this line is a -1/4. My y-intercept is a 0, 1. And then looking at my symbol. So this symbol right here, y is less than my line that I have. So I want all the y values that are less than my line, because remember, with an inequality, there's more than one solution. So if I want the y values that are less, I know I'm going to be shading below the line. So if I know I'm going to shade below the line, the other thing that I want to know, is it going to be a dashed or a solid line? And because there's no equal to sign on my symbol, then I know that this is going to be a dashed line. Okay, so let's do this thing. If we start with our y-intercept here of a +1, and then I'm going to go down 1 because of my slope, goes down 1, and I'm going to run 4. 2, 3, 4 puts me here. And then I'm going to go up 1 and back 4 puts me here. And remember, with this inequality, we want to put as many points as we can on our line, because a line is infinite, and so that we want to show it goes everywhere that we're looking at. So I'm going to go up 1, 2, 3, 4, up 1, 2, 3, 4. Now, it's a dashed line, so we're going to make this dashed. With my arrows, and I'm shading below. So everything down below That's what we're looking at. Awesome. That's all there is to it. Let's do another one.